Imagine you are the doctor. 59-year-old male, sudden substernal chest pain, throbbing, 9 out of 10, at rest, nausea, diaphoresis, dyspnea. And something unusual, the pain radiates to his left leg. Heart rate, 62. Blood pressure, 96/47, hypotensive despite a history of hypertension. Oxygen sat, 100%. Troponin elevated, T-wave inversions across the precordial leads. This is a real patient from the published medical literature, case PMC 3599030. What happened next almost killed him. Your AI app works 80% of the time. That sounds great, until you realize the last 20% is where careers end and patients die. We gave this exact case to 3 different AI models: Llama 3.1, Google's MedGemma 27B, Claude Haiku 3.5. All 3 diagnosed a heart attack. All 3 recommended heparin. But this patient has an aortic dissection. Heparin doesn't just fail to help, it causes catastrophic hemorrhage into the false lumen. 1 confident answer, 1 dead patient. Llama said, N STEMI, confident, no differential. MedGemma mentioned dissection as possibility number 2, then dismissed it and started the ACS protocol anyway. Claude Haiku diagnosed STEMI and went straight to the cath lab. None of them flagged the atypical radiation to the leg, none required bilateral arm blood pressures, none checked whether their treatment could be lethal if their diagnosis was wrong. No checklist, no safety net, no way to say, I'm not sure. That's the reliability gap, and it exists in every domain where AI makes high-stakes decisions. There's a better architecture, structured reasoning, grounded knowledge, and a confidence meter that knows when to stop and call for help. What if your AI could show its work? What if it knew what it didn't know? A reliability layer you bolt onto your AI application, composable symbolic reasoning, so your app works every time. Think of it as the safety harness for your AI. The AI does the climbing, the harness makes sure nobody falls. 3 layers, a rule engine that checks every step, a trust meter that scores confidence, and a human-in-the-loop gate that knows when to escalate. Your AI stays fast and creative. The harness wraps it in structure, evidence, and safety. Under the hood, it's a framework with 84 composable components. Each one does one thing well. Snap them together. Your pipeline, your rules. Goal decomposition breaks big problems into small checkable pieces. Knowledge grounding checks the textbooks. Expert inference weighs the evidence. Trust scoring decides what to do. 6 ways to deploy. Command line, REST API, MCP tool server, that's how AI agents use it, web app, gRPC, and SOAP. 4 operating tiers, each more capable than the last. T0, no learning at all. Fixed tool calling. Wire the model to its tools and run it. Performance jumps once, then flatlines forever. Most agent frameworks operate here. Use T0 when your task is well-defined and the right tools are already available. No iteration needed. Validated on Gaia, OmniMath, and GPQA Diamond, the standard benchmarks for tool calling agents. T1, harness engineering. A human studies the failures and rewrites the prompt or the harness around the model. The system stores that knowledge, but its learning rules stay fixed. With harness modifications alone, model held fixed. Big Bench Extra Hard moves 51 percentage points. MedExpert QA moves nearly 9. Long Bench V2 moves 6. Same base model, different harness around it. 1 adaptive traverse. A one-time push that locks in the improvement, then flatlines again. Stripe ships 1,300 AI pull requests a week, through harness infrastructure of exactly this kind. T2. Continuous resampling. Add a user feedback loop or a rubric the system runs against itself. It improves with every cycle, but it learns the same way every time. On GDP Val, 18 of 44 job domain agents pass at 70% or higher. On Tau Squared Bench, plus 46 percentage points after 6 self-training iterations. 2 adaptive traverses, data, and learning. The system improves continuously, but the learning strategy itself never changes. T3. Structured theory building. This is G6's native tier. The system figures out why it failed, writes an explicit theory of the problem, and applies that theory to cases it has never encountered. It learns how to learn. On HLE Verified, 0% to 70.2. On ARCAGI3, 3.3 to 44.3. On SWE Bench Pro, plus 20 points. 2 different coding agents, Claude Opus, GPT 5.5 via Codex. Same self-training loop, same shape of improvement. Back-end agnostic, by evidence. 4 tiers. G6 supports all of them. Inspired by Practopoiesis, Nikolich's framework for how living systems organize their own learning. Choose the tier that fits your problem. You're a vibe coder. You build fast, ship fast, iterate fast. You use Claude, Cursor, Copilot, whatever gets the job done. But when your AI app hits production, it usually works isn't good enough. Your users need it to always work. That's the gap between a demo and a product. It's your reliability layer. Keep building fast. It catches the edge cases, enforces the safety rules, and tells you when it's not sure. You ship with confidence. Let's see this in action with the real case. Our 59-year-old patient walks into the emergency department. This is published case PMC 3599030. Every detail is from the medical record. Sudden substernal chest pain, throbbing, 9 out of 10. Nausea, diaphoresis, dyspnea, and confusion. History of hypertension, hyperlipidemia, and prior lacunar infarcts. Troponin I elevated at 0.154. The 3 LLMs we tested all saw the same data. All 3 anchored on the elevated troponin. All 3 missed the atypical radiation to the leg. All 3 recommended heparin. Now watch what changes. Step 1. Break the big problem into smaller checkable pieces. The system decomposes the top-level goal. Diagnose and triage this patient, where both ACS and aortic bisection must be considered. 5 sub-goals emerge. Gather and structure clinical data. Retrieve and ground medical knowledge. Execute differential diagnosis via expert system. Verify against safety constraints. Generate recommendation with safety gates. Notice safety is a first-class goal here. It runs alongside the diagnosis, not after it. The recommend sub-goal carries a human-in-the-loop tag. Before any work begins, a solvability pre-flight runs. Like a pilot checking instruments. Do we have enough data and rules to actually solve this problem? Step 2. Check the textbooks. Before answering, the system retrieves relevant medical knowledge. Chest pain differential with cardiovascular risk factors, including dissection mimics. 849 paragraphs searched. 10 passages selected, including the critical fact, 26% of type A dissections present with ACS-like ECG changes and troponin elevation. Coverage, 87%. All 10 retrieved facts are relevant. The knowledge base covers the problem space. Above threshold, the system has enough grounded knowledge to proceed. If it didn't, it would stop and say so, unlike the LLMs which always have an answer. Step 3. Weigh the evidence. Think of a jury hearing testimony. 18 initial facts from the patient and the textbooks enter working memory. 12 rules encode medical expertise. A rule only fires when all its conditions are met. No guessing, no hallucination. Cycle 1. 3 rules fire simultaneously. Dissection hypotension warning, because the patient is hypotensive despite a hypertension history. Check dissection because chest pain plus hypertension. And require bilateral arm blood pressures. Cycle 2. The ACS rules fire 2. Elevated troponin and T-wave inversions trigger suspect NSTEMI. Classic presentation triggers suspect ACS. Now we have 2 competing hypotheses. Cycle 3. The safety dual diagnosis rule fires. When NSTEMI is suspected and dissection is flagged, require CT angiography before any treatment. This is the rule the LLMs don't have. Cycle 4. Dissection elevated suspicion fires, throbbing quality plus the dissection check. And then the critical safety rule, contraindicate heparin. Remaining cycles fire safety auscultation, dissection malperfusion warning from the confusion, and ACS risk factors. 10 rules total, 28 facts in working memory. Fix point reached. No new facts can be derived. The system has explored every path and every safety constraint. 10 rules fired, 28 facts. Complete audit trail. The Mycin combination formula weighs 3 independent reasoning chains. This isn't a probability. It's a structured certainty factor with mathematical backing. But the critical output isn't the diagnosis ranking. It's the safety actions. Heparin contraindicated. Bilateral arm BP required. CT angiography required. Cardiac auscultation required. Every one of these was missed by the LLMs. Step 4. The confidence meter. 3 independent scores. Think of them as 3 referees, each watching a different part of the game. Model quality, 85%. Rule chain accuracy, 92. Grounding coverage, 87. Weighted trust score, 89%. 89% lands in the supervised zone, above the floor, below the auto-approve line at 95. And for medical decisions, auto-approve is locked out regardless. Verdict: human in the loop required. Supervised action class. The system presents its findings, including the heparin contraindication, but a clinician must approve every step. The machine does the analysis. The doctor makes the call. What actually happened to this patient? The real hospital diagnosed NSTEMI and started heparin, exactly what the LLMs recommended. On the medical floor, someone finally checked bilateral arm pressures. Left arm 180/60, right arm 120/40, a 60 millimeter difference, the classic sign of aortic dissection. CT angiography confirmed it, Stanford type A dissection, from the aortic valve root to the iliac arteries. G6 would have blocked the heparin. G6 would have required the bilateral arm pressures. G6 would have demanded the CT before any treatment. Same data, different architecture, and a patient who walks out alive. 18 facts in, 10 rules fired, 28 facts out, a complete chain from raw symptoms to safety actions, with every leak visible. And this is just one case in one domain using a fraction of the system's capability. The same engine handles code analysis, legal research, financial modeling, scientific reasoning, any domain where reliability matters. LLMs generate tokens. This system traces inference chains. Different architecture, different guarantees, and you can train domain-specific rule sets on your own proprietary data. Numbers, and all of these come from harness modifications alone, with the model held fixed. SWE Bench Pro, 44%. The industry standard benchmark for autonomous software engineering. Can the system fix real GitHub issues end-to-end? Published, reproducible. Big Bench Extra Hard. The benchmark designed to break frontier AI systems. Plus 51 percentage points over the base model. Self-engineered harness changes only. No fine-tuning, no weight updates. Gaia, the general AI assistant benchmark for multi-step tool use. Plus 29 points. Same base models, same weights. Change the harness around them, and scores move by double digits. We publish our benchmarks, our methodology, and our failures because reliability requires honesty. Every pipeline run generates a complete audit trail. Which rules fired, which facts were derived, what the confidence scores were at each step. Run the same case twice, get the same answer twice. Deterministic where it counts, adaptive where it helps. The system builds its own guardrails from your data, your rules, your domain knowledge. Other frameworks promise reliability. LangChain gives you chains. Crew AI gives you agents. AutoGen gives you conversations. This gives you proofs, formal verification, grounded knowledge, confidence scores with mathematical backing, every inference auditable, domain-specific safety rules trained on your own data. The difference, they orchestrate AI, we verify it. One command, like typing a search query, but for structured reasoning. G6 composed chess pane, -- run. You pass a context file, a plain text description of the problem. The system decomposes, grounds, reasons, and scores. Verdict: human in the loop required. Full audit trail. One command. For your app, REST API. Send a question, get a structured answer. Every field in the response is traceable back to the evidence. For AI agents, MCP Tool Server. Your coding assistant or AI agent calls it as a tool, like a calculator for structured reasoning. 6 deployment interfaces, one engine. Drop it into whatever stack you're running. The web dashboard shows everything at a glance. Cycle count, coverage percentage, top certainty factor. The gold tree panel shows the full decomposition. Click any node to see which rules contributed. The reasoning flow shows every rule that fired, in order. Each links to the facts that triggered it. The approvals queue is where human in the loop happens. Review the differential, approve or reject the workup. 84 components, your choice which ones to use. Need just grounding? Pull in the grounding block. Need the full pipeline? Compose all 5 stages. Every component follows the same interface: input, process, output. Build custom pipelines for your domain. Train safety harnesses on your proprietary data. Swap components without touching your application code. For developers who want to extend G6 or build on top of it, the pipeline operator. Compose goal, ground, expert, and trust into your own application, or any subset, your rules. Medicine is one domain. The framework works everywhere reliability matters. The case study you just saw uses a tiny fraction of the system. Code analysis with formal proofs. Legal research with auditable reasoning. Financial modeling with confidence scoring. Scientific research with grounded knowledge. 32 specialized job agents across every professional domain, each built on the same composable framework, each trainable on your data, your edge cases, your failure modes, your regulatory constraints. Researcher tier, $20 a month Australian. 200 plus cognitive components with MCP integration, Claude Code support, built-in quality checks, and full visibility into what your AI did and why. Builder tier, $50 Australian. Everything in Researcher, plus multi-device, a dashboard to track what's working, automatic model routing, and a review gate, so you can sign off on AI decisions before they're final. 30-day free trial. No credit card required. Start building today. Every step logged. Every inference traceable. The system knows when to ask a human. Your AI app works sometimes. G6 makes it work every time. G6solver.com. Start your free 30-day trial today.